Hello everybody, welcome back to my channel. Today's video will be seeing again the methods of synthesis of nanoparticles. There are two methods briefly. One is precipitation method and one is for the CVD method. Okay. In this video we'll be seeing the precipitation method. So we're going to see preparation of copper oxide nanoparticle by precipitation method. Okay, so firstly let's understand what is precipitation reaction firstly. So say A plus B becomes C plus D. Take this as soluble. It's soluble in the solution, it's soluble in the solvent. This is the precipitating reagent, you can say precipitating agent, and reaction happens. This becomes your PPT and this is still soluble. So basically it's the precipitating reagent. Now how to prepare copper oxide nanoparticle if I'm going to say. Firstly we take CuCl2 aqueous. What does this mean? We're making a homogeneous solution. Means what are we doing? We're taking CuCl2 and we are dissolving it in the water, and this is soluble. This is homogeneous mixture. Then we are taking NaOH. This is a precipitating agent. Then most important, under certain pH, under certain temperature, under constant stirring, in the presence of capping agents, in the presence of all of these and other conditions, we will get CuOH twice plus NaCl. OH is twice, so 2 Na, so 2 NaCl. So this becomes your precipitate. This is the precipitating agent, and this is still in the solvent. It is still in the solution. It is dissolved in solution. That is fine. We are mainly concerned about this. Now, do you think this is a nanomaterial? No, this is not a nanomaterial. First of all, for nanomaterial to be formed, these conditions are required. But this is okay. We get a nanomaterial. Directly we don't get this as nanomaterial. What we have to do is we get CuOH. It is fine. This CuOH2, what are we doing is we are filtering the CuOH2. We are filtering it. We are washing it and drying it multiple times to remove any impurities. Okay, now this is residue CuOH2. Okay, now this residue CuOH2, what are we doing it for? CuOH2. Here CuOH2. This, what are we doing for this is we are going to make it undergo calcination. Now what is calcination? We are going to heat it in limited or absence of oxygen to remove volatile particles and form metal oxide. So this forms CuO plus H2O, and here we get our copper oxide nanoparticle. This is the method. And one more important thing, this is also known as the precursor material or the starting material, because this is only what is starting. CuCl2 we can take, and many other things also we can take, but I'm taking CuCl2 here. So CuOH2 calcination, we are going CuO and H2O. This is copper oxide nanoparticle. Now this method occurs in 2 steps. This precipitating method occurs in 2 steps. First one is nucleation. The second method is growth. These are not 2 methods. Sorry, I'm very sorry. This is steps, not methods, steps. First step is nucleation. So what happens is that the atoms of the reactant they group together to form nuclei, and that is known as nucleation. This nucleus, if the fast nucleation, if the fast nucleation is happening, that means small size nanoparticles are being formed, but they are many in quantity. If the slow nucleation takes place, if the nucleation is slow, that is atoms combine to form nuclei, that is what the process is called nucleation. If that is slow, that means big or large size nanoparticles are being formed, but they are few in number. Now these nuclei, what do? Is they attract other particles present in the solution, so that particles help increase size of this nuclei, so that is known as growth, and it starts growing, right? So this growth will decide if the formation of if the material formed will be nanomaterial or bulk. This or this will decide based on what? Based on if the pH is maintained, if the concentration is maintained, if the temperature is maintained, if the stirring is constant. Based on if all of this is there, then nanomaterial is formed, or else bulk material will be formed. So that was the two steps. Nucleation is what? Atoms are grouping to form nuclei. Formation is known as nucleation. If it is fast nucleation, that means many nanoparticles are formed of small size. If the nucleation is slow, that means big nanoparticles are formed of small size. This nuclei will attract other particles present in the solution. And starts accumulating on it. That is known as growth. This growth will decide if the material formed is bulk or nanomaterial. If the pH, temperature, concentration, stirring, all that is constant, then you will get nanomaterial, or else you will get bulk material only. And some applications, if I have to tell of this CuO, one is rocket propellant catalyst. In general, it acts as a catalyst in glass and ceramic industry, in magnetic storage device, then in gas sensor, then superconducting material, then solar energy application, etc. In many other things it's used. I've listed a few. So this was about copper oxide. I'll just brief it out very quickly. So what precipitation reaction you understood, in the solution, what the reaction is happening, and precipitate is formed, which is dissolved, which is insoluble, that part is known as precipitate, and there is known as precipitation reaction. So here we're taking CuCl2 and reacting with CuCl2 becomes the precursor material. We're reacting with NaOH. NaOH is a precipitating agent that reacts to form CuOH twice. It won't form under constant and a proper pH, temperature, capping agent, and constant stirring only. We get CuOH2 and NaCl. That balancing you can do. This CuOH2 we are going to pass through a filter, wash it multiple times, dry it, and then what we get, that we are CuOH2, that's the residue CuOH2, that we are going to undergo calcination. Means heating in limited absence of oxygen to remove the water substance and get proper metal oxide. Then we get metal oxide, right? Then that process is calcination. That we get CuO nanoparticle that time. Then this occurs in two steps. One is nucleation, that is atoms group together to form nuclei. That nuclei formation and nucleation. If the nucleation is fast, that means many small nanoparticles are formed. If the nucleation is slow, that means bigger and fewer nanoparticles are formed. Now this formed nuclei or nucleation, what has happened, there are other particles in the solution. It will grow bigger, that is known as growth. if the growth decides if the forming material is going to be nanoparticle or it's going to be bulk. If the proper pH, temperature, concentration, stirring is maintained, then it's going to become a nanomaterial, or it's going to become bulk. It's used in rocket propelling catalyst, glass and ceramic industry, battery storage devices, superconducting magnets, superconducting material, then gas sensor, etc. So that was about this video. In the next one we'll see CVD. Until then, take care, bye bye.